Today we're going to learn how to make a galvanic cell with the highest cell potential possible. So to begin with, we go back and look in the lab and see what we can find. And we have some copper solid, some gold solid, some iodine gas, 1 molar copper sulfate, 1 molar iron nitrate, and 1 molar gold nitrate, along with 1 molar of potassium iodide that we can use. So now what we need to do is we need to figure out how we can make the galvanic cell with the highest cell potential. So we can look up a list of standard reduction potentials, or maybe it's something that's given to you, if this is like a exam question or something of that nature. And basically what we want to do is we want to look at our list, and we want to start off by looking at our reactants and looking our way from our top and looking our way down to see what we have. So we get the one with the most positive value for our standard reduction potential. Now, one of the things that we'll notice is that this says that we have gold 3+, iron 3+, and things of that nature. Now, don't be confused, because what we have given to us are several 1 molar solutions. So what this is really looking like is if we look at our, say, copper sulfate. Our copper sulfate, when we look at this, we know that sulfate has a -2 charge. It's a polyatomic ion. And so we know that our copper is going to have a +2 oxidation number to counteract that. So that +2 correlates it to being a copper 2+ ion when it's in water. We can do the same thing for the other ones. We can have our iron nitrate. All right, our nitrate ion has a -1 charge, but we have 2 of them. So if we look at both of them combined, there'll be a -2 overall. So our iron is going to have to be a +2 for its oxidation number, meaning it's going to be iron 2+. Now this is our only iron at our disposal, so we don't actually have any iron 3+, so this one's going to be no good for us. We do have iron 2+ down here that we can use. All right, let's go and finish the rest of these out. We have gold nitrate. And again, our NO3 is going to have a -1 charge, but we have 3 of them. So overall, it's going to be a -3. And then for our gold, that'll have to be a +3. So we have gold 3+. And then lastly, we have our potassium iodide, where our potassium is going to have a +1. Our iodide is going to have a -1. All right, so now we can go back and look at our list here, and we're going to start at the very top and work our way down. So we need to look to see if we have any gold 3+, and we do. This is in our gold nitrate. So this is going to be our reduction potential we're going to use. So I'm going to go ahead and circle that so I know that's one that I want to use. Now we're going to be looking for our reaction we want to flip. So we need a oxidation half reaction. So we want to look at the bottom of our list here, because this is going to be the ones with the negative values. So after we flip it, the sign is going to change to positive. So we're going to be looking for the one that is going to become the most positive or the least negative. And we're going to be looking at our reactant side, or we're going to be looking at our product side, because this will become our reactants after we flip it. So we need to look to see if we have any iron. Looking at our list, we don't have any iron. We have iron 2+, but that's not solid iron, so that won't work. All right, and then we'll move up. All right, do we have any solid copper? And yes, in fact, we do. We do have solid copper. So this is going to be the reaction we're going to flip for our oxidation half reaction. So when we flip that, we're going to have copper becoming copper 2+, +2 electrons, for a standard oxidation potential that is equal to the opposite sign, so -0.34 volts. All right, So now we figured out what we want to use. Let's go ahead and see what our actual questions were. So what combination of these materials will yield the voltaic cell with the highest cell potential? And we're asked to write this as a cell diagram. Well, we already figured out what species we want to use. We want to be using our copper for our oxidation half reaction and the gold 3 plus for our reduction half reaction. So we always want to start off with whatever is producing electrons. In this case, it's going to be our copper solid. And so we're going to start off with our copper solid. Then we'll draw a line for a phase barrier. And we can choose anything we want to put in here. Normally we want to choose something that doesn't cause side reactions. So I just want to choose something with copper 2 plus if I can. So in this case, it'll be our copper nitrate. Or sorry, excuse me, copper sulfate. Then we'll have a salt bridge. And then finally, we can go to our gold reaction, where we're going to start off with gold 3 plus. In this case, our gold 3 plus. In this case, this is going to be gold nitrate. Then we can go through a barrier, and then we need to choose some electrode that's going to be inert. Now, really, the only two electrodes we have at our disposal right now are copper and gold. So I don't want to put copper in there because that might cause some side reactions. So we're going to go ahead and choose gold. All right. So let's go ahead and take a look at this if you want to have a little bit better handwriting. And then we have one more question, or we have two more questions. What is the cell potential of your cell? So in this case, all we want to do is we want to add up both of our cells here. So we have our reduction potential of positive 1.5 and our oxidation potential of negative 0.34 volts. So when we add those together, we should get something a little less than 1.5, giving us positive 1.16 volts. Then we come to our last question, and it's asking what is being oxidized. So to figure out what's being oxidized, we can find which reaction we flipped. So this is our oxidation half reaction, and we just want to put whatever that reactant is. If we're asked what was being reduced, we look at our reduction reaction, and we could put gold 3 plus. But it's asking for oxidation, so we'll put our copper solid down here. All right, so again, this is how you can make your voltaic cell with the highest cell potential. You want to, again, make sure that you look at your reactants and look from the top down if you have a range from highest values to lowest values for your reduction potentials. And you want to make sure you actually have that reactant. If you don't have that reactant, you have to move down the list and look at the next one. So you're looking to see whichever one you actually have available. Then you want to look at the bottom of the list and work your way up, trying to find whatever you have available for your products, because that'll flip and turn into a reactant. Anyway, I hope you found this video useful, and I look forward to seeing you in the next video.